In this video, we're going to look at database modeling, and there's a few things we're going to be looking at within here. So we're going to look at data flow diagrams, we're going to look at entity relationship diagrams, and then later on we're going to look at data dictionaries. So we're going to start off with data flow diagrams, and a data flow diagram is a method of showing the flow of data within a given system, and what you can have within it is various different inputs, so something that goes into the system, and then the output of the data, no matter what it might be within the company, it might be outside of the company, etc. We're going to look at things like processes that happen within the business or system. So you may get your data that goes in, it's going to be unsorted or whatever it might be, and then you process it in some way. So it might be it goes into a database, and then you run reports or you run queries and so on, and then the output is what comes out of that, and that might go to somewhere within the business, or it might go somewhere without the business. Sorry, outside of the business. There are two different types of data flow diagram created by two different sets of people. You don't need to worry about the ins and outs necessarily of those, but you can look it up if you are so interested. They both date back a reasonably fair way. You've got Jordan Code, whose data flow diagram is mainly for systems analysis and design, so in other words coding, software development, and you've got Gain and Sarson, who developed the DFDs mainly for things like business modeling. So there are slight differences in the way that they look, but in reality, I mean, ultimately there's not massive differences between them. The shapes are slightly different, but in terms of what you're doing with them from an IT perspective, you're probably going to use the Jordan and Code one, but in the long run, I mean, you're not going to be too badly off even if you kind of use one or the other. What you shouldn't be doing is obviously mixing them up, because then you're going to get this fusion of different symbols, and that's not what you want. You want to use one or the other. And there's a couple of different differences. So you can see that the external entity, so that's something that is outside of the business, maybe a customer, or maybe another company, is the same for both. Where we've got colours in here, the colours just kind of signify that they are different. In the outside world, you don't have to put any colours in there whatsoever. The process is obviously different. So you've got a circle for the ordinary code, and you've got what looks like a rectangle with curved edges for the Gain and Sarson. Data store is pretty similar, and the data flow is represented by an arrow. Now, when you are creating a data flow within your data flow diagram, you're going to need to actually label these and say what data is flowing between where. So you don't just have the arrow with nothing there. You need to label it so you can actually say this is what data is flowing from point A to point B, whatever it might be. So just a couple of bits to bear in mind with data flow diagrams. You must have an input and an output. So something must be inputted into the data flow diagram in order for any data to be flowing. If no data is put into it, then you're not going to have any data flowing. I mean, it's pretty straightforward, really. And obviously, when you put data in, you're going to have an output somewhere in the system, whether it be inside or outside of your business. Each data store should have an input and output. There's no real point in storing data if there's no output. And obviously you're not going to have anything stored in there if there's no input. So that's pretty common sense. And all data stored in the system should go through a process of some point, whatever that might be. There are a number of different data flow diagram levels, and you can look these up in more depth later on. So you've got level 0, which is the contextual model, which is the overview of the process or business. Generally, if you're doing these type of diagrams, you're going to want something in a bit more depth than that. So you'll at least go probably to your level 1, which is the main processes of the system. And at this point, you're kind of delving a little bit more kind of into the actual system itself. You're still generally looking at the overall system, but you're highlighting the key parts within it. Your level 2 is where you start to actually look at maybe specific parts of the system, and you can actually kind of highlight specific sections within it, so that you might be able to, if something is going wrong somewhere along the lines, that you're helping to kind of pinpoint it. Level 3 and above, you can get examples of these very rarely, because the level of complexity goes beyond what we will need at most points. So, and especially if you're looking at a level 1, I don't know why I said level 1, a level 2 or a level 3 education, of course, you're unlikely to need any more than probably a 1, really. I mean, a lot depends on how complex your system is. Entity relationship diagrams will show you the relationship of entities within the database. So remember, entity is something which you will store data about within the database. So if you are thinking about a education institution, then an entity could be a tutor, an entity could be a student, and then you have attributes of those. So if you have an entity which is a student, attributes of that are going to be age, they're going to be course, they're going to be date of birth, and so on. So obviously, within, if you are holding it about a student, you may find that, just going slightly off topic, that age, for example, has quite a big impact as a student. Things like funding, things like once a student hits 18, then they are an adult. So in effect, you don't actually need to deal with their parents and so on. But entity relationship diagram is where, when you have organized your table, normalized it, you should be looking to join the tables together, and this join is called a relationship. And what it will mean is that there are a number of different types of relationship that are available, and if you have a one-to-many relationship, then you will have a data stored once in one table that is able to be used many different times in another table. So an example of that is maybe a customer database for an ordering system of some kind, and you have your customer table, and you only want, if you have a customer's table, for the customer to be stored once. But however, that customer can then make many orders. It's not very good business for a customer only to come and make one order. Generally you want repeat custom, and it could be used over and over and over again. And there are a few examples of that. And I'm not necessarily going to go into massive detail here, because we discuss it elsewhere in terms of the actual types of relationship. But an entity relationship diagram will actually kind of link these things together, and the idea is that you're planning this ahead of time. So this is just an example, and you can see there's lots of different joins here. So you have your entity, which is the title of each one of these tables. So you've got supplier, customer, order, product, item, and shipment, and then within that you've got your various different attributes, which are all called item 1, 2, and 3, and you've got your relationships between them. And in your table, in your diagram, you will actually replace the item 1, item 2, item 3 in each table with whatever the fields actually are. And you would have as many different fields as you need, not just the 3. But once you've normalized your table shouldn't be that big anyway. So a few different types of relationships, so bear in mind this when you are mapping it out. There is various different software out there that can help you do this. I've not tried it in Visio, but I'd imagine it's available in Visio. If not, then there are other different types of software out there. And if the worst comes to the worst, it's not a particularly difficult thing to draw in Word or something like that. So you've got a number of different relationships. So you've got the one-to-many there, and what you would have, hopefully eventually my mouse will come onto the screen. Here we go. What you have is you would apply this to both ends of your relationship. So one end might be a 1 and the other end might be a many, or the other one might be a 1 and only 1, and then the other end might be a standard 1. So this is when you have your relationship, you need to apply something to both ends. Okay, so it will be one of these. Now, obviously, we can get potentially many-to-many relationships. That would mean that your database is not normalized properly, and you're going to need to go back and have a look at it again. But just be aware that things like one to many is probably the most common out there, or a 1-to-1 is quite. It's not going to be quite as common because you don't want, for most databases, only a single occurrence of something, but especially if you're selling something. But it's just something to bear that in mind. You can find these shown in quite a few websites in case you need them. Here's some examples of it. So you may have a customer and an order, and as you're kind of making this thing, you're thinking, okay, well, one customer can have many orders, but actually the customer doesn't need an order to exist at all. Okay, so in this instance, you've got the one to many or none. However, here, when we go back the other way, you can think of, okay, well, you only want one and only one customer in this table, which is where this drawing comes in. Something to bear in mind when you're doing this is that when you are planning these relationships out in an ERD diagram, it will look different to how it looks in Access. Okay, so the many sign in Access is like an infinity sign, like an 8. Can get a little bit confusing in that respect, but just bear in mind, ultimately the idea with an ERD diagram is that it is a plan. Okay, and the idea is that you're planning it out before you are doing it, and that in the long run is going to save you time, we would hope. Data dictionaries. So a data dictionary is where you are taking all of the different parts of your database, of potential data that you have within your database, and you are listing it and you are planning it, and this will prevent things such as if you have data stored in two different places, potentially in different ways. So let's say, for example, you might have a date of birth field which in one place is DDMMYY, and in another place could be DDMMYYYY. Okay, now while that is only 2 extra characters, that means that you're going to have the same data stored twice, and if you update it in one place, it's not going to be updated in the other place, which is not something you want. One of them is going to be wrong. It's not something you want. And the idea with a data dictionary is that, again, you are planning this out beforehand. You are saying, okay, we're going to have the field name, we're going to have the data type, the format, field size, description, and example. These are relatively straightforward stuff. And that you're going to plan all this stuff out before you actually start, which in theory will help you long term, and will help you if you need to reuse the data at any point as well, or maybe perhaps use it elsewhere. So this is just an example of this, a very basic one which I've shamelessly stolen from somewhere else, and it's pretty straightforward stuff. You've got your field name, you've got your data type, you've got your data format here, which can be whatever you want it to be really. You've got your field size, a description in case it's unclear exactly what the field means, and then an example. So obviously, for most databases, you're going to have way more information than what is in this data dictionary, but this is just an example of the way that it should be set out and the types of things that you could be including. Thank you very much for watching. Hopefully that has helped, and I'll hope to see you all soon. Thank you. Bye-bye.